Hi everyone, in this video we are going to discuss what happens when two atoms come together. So why does something form a bond, or why do two elements maybe not form a bond? And so it turns out that it all has to do with energy levels. So let's start off by talking about our simplest atom, right? So hydrogen, one proton in the center and one electron on the outside. So here we go. We have two different hydrogen atoms, and they start off at a certain energy level. So something like this. We'll just say this is hydrogen B and this is hydrogen A. It doesn't really matter, but they start off at a certain energy level. So for this example, our energy is going up. And so at this point, we have one nucleus right here, and we have one nucleus right here. So let's say we bring these toward each other. So they're going to bring them toward each other here. So remember, this has one proton in the center and one electron on the outside. So what's happening is when they get close enough together, this electron on here is actually attracted to the core of this atom. So if I were to draw this as just the nucleus by itself, there's a big proton sitting there. So that electron is attracted to this proton, and in the same way in the opposite direction, this electron is attracted to the core of this proton. And so what's going on here is as we bring these things closer together, what we found is their energy level actually droops. So it gets lower and lower and lower, which is a good thing. Nature is always trying to get to a place of lower energy. Think about when if you're just to stand up, it takes a little bit of energy, but the second you sit down or relax into a couch, you're like, whew, this feels great. It just feels better to be at a place of lower energy. It's the same exact thing with atoms. When you're at a lower energy, you're more stable, and these atoms are actually happier, if that makes sense. And so as you bring these things closer together, they actually get more and more stable to a point where there's something right at the bottom. So here, let's say at this point, the atoms are like this close together, and so they're pretty happy. This electron is attracted to this proton, the same way the other way. And then you get closer down here, they're really close to each other, the electron's attracted to the proton, and then you finally get to the spot of a happy medium. And so this is its favorite place. It loves, loves, loves being super close to each other. So maybe you would draw it something like this. So your two hydrogen atoms are next to each other. The proton is attracted to the electrons, but the proton-proton repulsion, so the core of one, so it's very, very positive, and then the core of the other are not pushing each other away. And so there is a spot where they can get too close, and you have these repulsions. And so it's the same way I always describe it as like there's a creepy guy maybe at the gas station, you're trying to just get your soda or whatever, and he's too close, and you're like, boof, just get away from me. It's that same thing. Our cores are too close to each other, we don't like it. And so you push each other away, and there's this perfect distance that makes you happy, I guess. And so for this example, when we have the two hydrogens next to each other, it's this perfect spot. There's this perfect distance when they are apart from each other that provides a place of lower energy or stability. So when you're right here at the very bottom of your energy well, you're at the most stable, and that is simply because you're at your place of lowest energy. So now, if these two things came together and we actually found that they went up in energy, and so they were like this, what do you think? Do you think that would be stable? Would it form a bond? So here's my actual question. I want you to think about that. So, will two atoms form a bond if their resulting energy is higher than their corresponding original, that's the important part, energy levels? Take a second and chat this one out, because I really want you to think about it conceptually what that means, okay? Go for it. Did you get an answer? It was a little tricky, so if it didn't just pop in your mind, that's okay. But the correct answer is no. If we have two atoms that are sitting at certain energy levels, and when we bring them close to each other, they actually end up at higher energy, they are never, ever, ever going to form a bond. There's no driving force, there's no reason for the two to come together and form that bond. Okay, so I know we're getting a little bit deep into energy levels, but there's a reason we need to talk about this. We need to figure out why things form either a covalent or an ionic bond. Now, a covalent bond is very simple. We've talked about them already this semester, but it is essentially when you have two atoms that come together when they share electrons. Okay, share is the key word. It's typically two nonmetals, not always, Okay, it's never always in chemistry, but it's typically two nonmetals. The opposite of this would be something called an ionic bond. Now, an ionic bond is when two atoms come together and they transfer their electrons, okay? And this is, again, not always, but often, one metal and one nonmetal. Okay, so it's the difference of, like, if you're on a date, and so this is a good date. Covalent bond would be a good date. So you're at the movies, you've got this big bag of popcorn in front of you, the two of you are perfectly sharing, you're eating it, he eats a little bit, and then you eat a little bit, and everyone's all happy and great puppy love. That's a covalent bond. You're perfectly sharing these electrons. Each atom is perfectly content, they're loving it. An ionic bond is when you're on a date with just this awful, terrible guy. He's sitting there, he's eating all the popcorn by himself, he won't let you have any of it because he took all of your popcorn. It's a transfer of electrons. It's a transfer of the popcorn. He's never, ever, ever going to share the popcorn with you. That's considered an ionic bond, okay? It's the difference of how your electrons are being shared or transferred between two atoms. So now, let me ask you a question. If I were to put sodium and chlorine together, I want to know what type of bond they would form, covalent or ionic. Go. Did you get an answer? Hopefully you did. The correct answer is that they would form an ionic bond. It is definitely where chlorine is a nonmetal and sodium is a metal. The two of them would come together and fully transfer their electrons, okay? So what happens is sodium has one electron and chlorine just takes it. It grabs its electron. It definitely forms an ionic bond. All right, so now the next one I want to ask you is what would happen if oxygen and bromine came together? Covalent or ionic? Go. Did you get an answer? Hopefully you did. This would definitely be a covalent bond, okay? They're going to share electrons. There's no way that either one of them is just going to give each other their electrons. That's not going to happen. They are covalent. They're perfectly content sharing their electrons. Now, the last thing I want to introduce is just the difference between a single, a double, or a triple bond. Okay, these are all different representations of a type of covalent bond. So a single bond is when you're sharing two electrons. A double bond, you just draw two lines, that's when you're sharing 4 electrons. A triple bond, that's when you draw 3 lines, that's when you're sharing 6 electrons. So let me ask you, just if this makes sense, what type of bond, single, double, or triple, does cyanide have? So let me draw it out for you. Okay, and it has an overall charge of -1, but that doesn't matter at all. What type of bond is this? Single, double, or triple? Go. Did you say triple? If you said triple, that is absolutely correct. All you have to do is count the number of lines. We have 1, 2, 3 lines, definitely a triple bond. Take care of yourself, drink water, have a great week.